Welcome back to Algebra 2. We're in lesson 121. We learned to graph the solution to quadratic inequalities like this one and like this one by looking at the sign, the inequality sign itself, and determining what this should equal. Right? If it's greater than 0, we determined it has to be a positive number. And if this is less than 0, then all of this must equal a negative number. So what we did was we would factor these out. And in this case, we have x minus 3 times x plus 2. Because they're the same on both sides, I'm going to go ahead and just write that in. Right, so we decided that we remembered that in order to get a positive number on this side, we either had to have a positive times a positive or a negative times a negative in order for both of those to be greater than 0. We need to figure out which one of these sets actually did that, actually gave us what we were looking for. And over here, in order for it to be less than 0, we had to have a negative, so it had to be either negative times a positive or a positive times a negative in order for those to be less than 0. And so we would try both of those out just to see which one of those fit, which one of the solutions made the most sense. So remembering this, let's jump into our first example problem. We are going to do the same thing, only we're going to learn how to do it with fractions. Alright, so our problem states graph 1 is less than or equal to negative 1 divided by x minus 4 in the domain of the reals. So here is what we would do. Our first instinct, given all that we understand about algebra, our first instinct is to multiply by an x minus 4 to eliminate the denominator, and that would be correct. However, if that happens to be a negative number, we could change this. And it being a negative number all alone would make this an incorrect statement, because it would change this and we would have to change the sign. But because we don't know if it's negative or not, we don't know if we have to change. So it just creates a whole bunch of confusion. So what we're going to do instead is we are going to multiply by this squared, because if it is a negative number, squaring it makes it positive. If it is a positive number, it just remains positive. So that is why we're going to square the denominator in order to get rid of it. So what we'll do is we'll write it out, x minus 4, if I can actually write it out correctly, x minus 4 times x minus 4 times 1 on this side. So that could be positive now. And negative 1 over x minus 4 times x minus 4 times x minus 4. And the reason I wrote this out instead of just writing it with the exponent of 2 is so I could do this. So I could actually see myself canceling this out, and I could show you how to cancel it out as well. Plus, now we're going to have to do the distribution. So on this side, we're going to go ahead and solve. It's going to give us x squared minus 8x plus 16, all of that times 1. Excuse me. All of that times 1 just stays the same, so we leave it. On this side, we have a negative 1 times x. That's going to give us a negative x, and a negative 1 times negative 4. It's going to give us a positive 4. But we want to set this all equal to 0 so we can determine what we have. So I'm going to add x and subtract 4 from both sides. Add x and subtract 4, and that's going to give me x squared minus 7x plus 12 is less than or equal to 0. And we did all of this and all of this to keep this sign in the same place. Because if we change it, we might change it wrong. We don't know what the number is yet. Now we're going to factor this, and from here, it's the same as we've done before. From this point on, it is the same problems that we learned previously about factoring and looking at the inequality sign to see if it should be a positive number or a negative number. So we're going to just factor it. And this ends up being x minus 4, x minus 3, less than or equal to 0. Because this is less than, then we know this has to be a negative number, right? So in order for it to be a negative number, it has to be either positive, negative, or negative, positive. So we're going to do that over here. So let's do positive, negative first. And then we'll do our negative, positive. See what we get. So for positive, it's got to be greater than 0. So x minus 4 has to be greater than 0. For negative, it needs to be less than 0. And that's going to be equal. You can't, if it says equal here, you have to put the equal there too. So x minus 3 is going to be negative. It's going to be less than or equal to 0. And for our negative over here, same one, x minus 4 is going to be less than or equal to 0. And for the positive, x minus 3 is going to be greater than or equal to 0. Now we have everything set up. I'm going to draw my little separation so I can keep it straight. And now we just solve them. So x, add 4 to both sides, is going to be greater than or equal to 4. X is going to be less than or equal to 3. Over here, same thing. X is going to be less than or equal to 4. And x is going to be greater than or equal to 3. So now that we have gotten here, we're going to evaluate these. Remember, this is our OR line, and these are ANDs. All right, so let's look at this. This is impossible. X is greater than or equal to 4. First of all, remember, before we start looking at solutions, let's look up here. It cannot be 4. X cannot be 4. Because if it's 4, then that would equal 0. 4 minus 4 would be 0, and you cannot have 0 in the denominator. So x cannot equal 4. All right. So now that we've established that, we can also see that this is impossible. There is no real number that is greater than 4 and also less than 3. We can't. So this set is impossible to graph. This set, on the other hand, the total solution comes from the conjunction on this side because we can do this. And we can graph it also. But remember, because x cannot equal 4, this has to change to x is just less than 4. Because x can't equal 4 because of what the denominator would end up being. So our answer is going to be, so I'm just going to write it here. X is less than 4 and greater than or equal to 3. So we would have a 3, we would have the 4, we would circle both, fill in the 3, and then let me use this red. And then draw our line because it's reals. And that would be the way we would graph that solution set. All right, easy peasy. So let's move on to example number 2. So the first thing we note when we look at this, it's the denominator is m plus 2. So that tells us that m cannot be equal to negative 2, because if it's equal to negative 2 plus 2 is 0. So let's go ahead and make that note before we even get started. It cannot be equal to negative 2. All right, so that's a fact. Now we just do the same thing we did before. We are going to take our denominator and we're going to multiply it twice to make sure that it's a positive number whenever we do the calculations. And we don't, that way we don't have to change the sign because we won't know if we need to or not. When you have that unknown as part of your denominator, dealing with inequalities, it's better safe than sorry. All right, so now this one is going to cancel and this one's going to cancel. So that leaves me m plus 2 times m minus 2. And I'm going to go ahead and do this bit. It's going to be m squared plus 4m plus 4. And this one's going to be m squared. And the positive 2m and the negative 2m cancel each other, and that's going to be a minus 4 right there. Less than or equal to 2m squared plus 8m plus 8. Now to get this equal to 0, I'm going to subtract m squared and add 4 to both sides. And that gives me 0 is less than or equal to m squared plus 8m plus 12. And I always like to have it on the other side, so I'm going to flip everything around just because I like to read it that way. The most important thing you have to remember is that the sign, the point, the less than, has to point to the 0 because that's the way it's sitting here. So m squared plus 8m plus 12, and I'm going to make the open side open to this. So it's the same thing. We just use the reflexive property so that we could flip it just so it's in the format that we're used to looking at it in. And when we do the reflexive property, when we have inequalities, we have to remember to swap the sign so that the greater than and the less than are still pointing to the right sides or to the correct values. So now we're just going to factor it. This is from the point that we normally do it on. It's not a super difficult concept. You guys are going to pick up on this really, really easy. From here on out, you're just doing it the same way we used to do it. So m plus 2 and m plus 6 is greater than or equal to 0. Because it's greater than, we have to have a positive. So that is going to be positive, positive, or negative, negative. So let's do that over here. All right, so we are going to put in our positive. We have m plus 2 is greater or equal to 0, and m plus 6 is going to be greater than or equal to 0. Our negatives are going to be m plus 2 is less than or equal to 0, and m plus 6 is going to be less than or equal to 0. All right, so now we solve. M is greater than negative 2. Notice I didn't put the equal to because we know it can't be equal to. So I'm just taking care of that ahead of time instead of at the end like I did with my other problem, or the previous problem. M is greater than or equal to negative 6. M is less than, and I'm not going to put the equal to in here, negative 2 because of this right here. And m is greater than or less than or equal to negative 6. All right, so now let's look at those as sets. So any number greater than negative 2 is certainly greater than negative 6, right? So we know that we can do this value here. All right, and it would cancel out that value. And any number, let's see, that is less than negative 6 is certainly less than negative 2. So that means we can use this value set right here, right? So, but we cannot include the negative 2 here. We're not going to do that. So this cancels. So when we graph, we are going to graph it like this. We're going to have our, let's do, start -8, -7, -6, and so forth and so on, all the way until we get past this. So it will actually, I'll go ahead and do 0 too. Give myself some more line. 1 and 2. All right, so that way I have something that you can see rather than just stopping at the end. So if m is greater than or equal to -2, it can't be equal to -2. So we're going to circle. I always forget to change the color. I'm going to circle the 2, and we're going to go off in that direction. And we're going to circle and fill in the -6 and go off in this direction. All right. And that's how we would solve that set. All right, so let's look at, that's it. That's all we have, actually. So I will see you guys in lesson 121. If you have any questions about when you do what, please let me know. Feel free to ask and I will help you out. I'll see you in lesson 122.